Hello students, if you remember in last period we have completed that chapter. Now we are going to start a new chapter, AC circuits. As its name says that it's AC circuits, might be all of you have heard about this AC and DC. Apart from this AC, DC is also there. All of you might have learned this AC and DC in your 10th standard or in your high school level. All of you will know about this. Still we will see what exactly AC and DC means. The AC means what? The signal which varied with time, that is said to be AC, alternatively changing. That is said to be alternatively changing. When current or voltage is varying with time, that continuously varying with time, then that type of current or voltage is said to be AC voltage or AC current. For example, I can draw it here. Suppose I have drawn it like this. This is suppose wave, just the two axes I have drawn, and if the wave is going like this, start at 0, goes up and again come down, again becomes 0, and so on. Such type of wave. Suppose this is nothing but a current. So this is a current I changing with time. Suppose current I changing with time. So here this wave represent variation of current with time. Here time is varying sinusoidally. So this type of AC is said to be AC current, because it is current we are showing. If we show the voltage which is varying with time t in the same pattern, then that is said to be alternating voltage. So these are nothing but AC signal. AC signal in short is nothing but what? Voltage or current changing with time. That is said to be AC signal or AC current or AC voltage. What about DC? So these are the two axes again. This is the time and this is suppose current I we have taken. And in this situation, current is not changing with time. It remains constant, exactly parallel to x-axis. It is not changing. It is constant. It is not changing with time. That type of current is said to be DC current. If it is a voltage, again it is not changing with time, then that is said to be DC voltage. So in short, AC means the signal which changes with the time. DC means the signal which remains constant over time, which will never get changed. That is said to be DC. Now here there are basic part of this chapter start with this I. I is a current generally, V is a voltage, or E is a EMF we can say. In your book they have used as a E as a EMF they have used lot of times. Now here what we have to see, we have to see here the basic part. That basic part is what? That is nothing but suppose the current is represented by I and EMF or voltage is represented by E. So if we represent voltage E equal to E0 sine of omega t, in this situation this sine omega t is nothing but a trigonometric function we know. As time here EMF means voltage. E is changing with the sine wave with time. That's why it is a function of time represented by sine omega t, where E0 is said to be peak value, maximum value of EMF. That I will told you later on. Similarly, we can represent the current by the different equation I equal to I0 sine of omega t plus something alpha, where sine omega t is a function which represents that current is changing with time sinusoidally. Alpha is a phase difference between EMF and the current. Again, I0 is a peak value. Now what exactly the I0 is? In your book they have drawn such type of diagram. Y-axis and x-axis they have taken. Such type of thing they have drawn in your book. So according to book we will go little bit such type of thing. Just they have drawn single wave. I have made 1.5 wave. So they have just given here 0. Okay, they have given this as 0 in your book. This should be the pi by 2. This is a pi by 2. This is the pi. This would be 3 pi by 2. And this would be the 2 pi. So in this fashion the wave is varying, and this axis will represent change in time with omega t we have taken. And this along y-axis, suppose EMF is taken, along this EMF is taken E. This EMF we are represented by this. So this is sine wave. The EMF is changing with omega t, so it is sine omega t is taken. Okay, E depend on sine omega t. Now what is this E0? The maximum value or peak value of EMF either in positive direction or negative direction. So this negative here. So here this peak value, maximum value, it is said to be peak value, and that was represented by E0. Now this equation represent how the EMF is changing with omega t. It is changing sinusoidally, that's why sin omega t function comes. E0, it has maximum value E0, it is plus, here it is minus. Basically this is plus E0 said to be, this is negative direction, minus E0, that is said to be peak value. Same way you can draw the diagram for current. Only difference is that alpha is a phase difference. If E start here, I may start a little bit down or just a little bit above with a phase difference of pi. So that is nothing but these things. Now let's go to next topic of the same chapter. That is nothing but a average value and RMS value. What is meant by average value and RMS value? So let's start with the average. Average value of current and EMF we have to see. Average value of current and EMF we have to see. What is the average value of sine along a single cycle? Just we have seen it goes positive, comes 0, again goes to negative. In one half cycle like this, what is the value of sine theta? Sine theta or sine that particular thing, average value of current or EMF over a cycle, sinusoidal single cycle, is always 0. So here we can't get any average value. Means what? It is not calculated at certain point. It is calculated within the 0 to 2 pi. 0 to 2 pi. What is the average value that was calculated? I will try to explain you by the diagram. So suppose this diagram, we start from 0 here. It goes here, again goes here. Here it is 2 pi. Okay. Here it is pi. Here it is somewhere pi by 2. Here it is somewhere 3 pi by 2. Such type of wave is there, that is nothing but a sine wave we have drawn. When we start here, it will start at this point and suppose it will end at this point A. O to A. The wave start at O, wave ends at A. Within this time span, if we see, this positive part is there and this negative part is there. So this positive part cancel with this negative part. So when we move from O to A, what is the average value? Average value is 0. That's why every sine or cosine function, their average value is always 0 over a cycle from this part to this part, O to A. It is single cycle. Over a single cycle, average value of sine or cosine term is always 0. Now what we have to do here? We have to find out how to find the average value of sine curve or cosine curve. So according to book, they have done a sine curve. So we'll go to the average value of sine from 0 to pi. 0 to pi we are going to find out. So 0 to pi means it starts from 0 and we are going to find out it as a, this is pi by 2 we know, and this is nothing but a pi. So within this pi we are going to find out the average value of this sine curve. So how can we find out that average value of sine theta represented by in this bracket sine of theta of this bracket, that means nothing but the average value, and that is equal to, that can be written as equal to, how can we find out? Over a one cycle we have to take where varies from 0 to pi, integration 0 to pi, sine of theta into d theta, and theta varies from 0 to pi again, so 0 to pi d theta. So sine term over 0 to pi divide by theta over 0 to pi. Their average, their ratio will find out, that is nothing but average values. So here, if you put here, just find out that the integration of this thing, sine theta, integration of sine theta, we know it is minus cos theta. Those who have mathematics, they are well known about this. Those who don't have mathematics, don't worry, directly remember this. Sine theta integration is minus cos theta, where it varies from 0 to pi. Limits. Theta, integration of d theta is what? Theta. It varies from 0 to pi. The upper limit minus lower limit, if you put the values, upper limit minus lower limit, it comes to be 2 divided by pi. Simply it comes to be 2 divided by pi, and 2 divided by pi means what? 0.637. 2 divided by pi, that comes to be 0.2637. Now might be you understand this. Now some of you might have some question that how this value come to be 2 by pi. Just we will see this one. So cos theta, upper limit is pi, lower limit is 0. How can we write? Minus cos of pi minus cos of 0 degree. Okay, divide by theta. Theta is what? For upper limit, put pi instead of theta, 0 instead of theta. Pi minus 0. So if we solve this, cos of 0 is 1. Cos of pi is minus 1. Same can be written as minus of minus 1. Cos of pi is minus 1, minus 1. And here divide by pi. Minus 1 is what? It is a minus 2. Minus 2 into minus, it is 2 divided by pi. In this fashion, this 2 divided by pi value comes. Those who don't have mathematics, for them I have solved this. Put upper limit first. Instead of theta, put pi. Cos pi, then 0 minus cos 0. Just put the value with minus sign common. Just we get 2 by pi. And that 2 by pi is come to be 0.637. That we have find out. From this, how can we write? We can write here the value of average current represented by I average. Value of average current can be represented by I average, and EMF is represented by E average. E average means average value of EMF. I average means average value of current. It is equal to I0, 0.637 into I0. Just we can write 0.637 into I0, peak value of current. Similarly, 0.637 into peak value of EMF. That will give the E0, the average value of EMF. Average value of current can be find out by this method. So this is said to be average value of EMF and average value of current that we have drawn. We have just derived from this equation. Now similar to this, we have to see RMS value. RMS value of current as well as EMF. RMS stand for root mean square value. RMS stand for root mean square value of current and EMF. Now see, might be all of you are well known about the meters we are using, or moving coil galvanometer or ammeter, that we are used to measure the average value of EMF and current. But for AC, while measuring average value of AC using voltmeter or ammeter, that is not possible, because average value of any AC is always 0. That we have seen, positive part cancel with the negative part. So average value of any AC is always 0. Then how to measure these things? To understand this, the new concept come into existence, that we should find one property of material which will give the same change, and according to that change we can measure that average value of current and EMF. And that property they have drawn, that property is said to be heat. That property is said to be heat. Suppose I0 amount of current is flowing, I0 or I amount of current is flowing, I amount of current is flowing to some conducting wire for a time period T. I amount of current, AC current, I amount of AC current is flowing through some wire, metal conducting wire, whose resistance is R, and the current is moved for time T. Suppose this wire we have taken, this wire, through this current I, means AC current is moving, the wire has a resistance R, and this current is moving for a time T. Then how much heat is produced in this conductor, that can be find out. Suppose H amount of heat is produced. I is the AC current, passes for time T through the conductor whose resistance is R, then amount of heat produces H, suppose. Now here is, instead of passing this AC, here we have passed AC. Let's take a second case. In second case, this I is again same, current passing for time T, T is again same, resistance of coil is same, wire again same, but instead of passing AC, we have passed IDC. Instead of passing AC current, suppose I have passed DC current to this for same time and through the same resistance material, same wire, same time period. Instead of AC only, I have passed DC current. Then if it will produce the same amount of heat here, if it will also produce same amount of heat here, then this DC value of current is said to be root mean square value of current, and that was represented by IRMS, and that we have to find out here. Same thing they have explained within these 5 to 6 lines. So just find out the value. I hope you got, when AC current pass through the conductor whose resistance is R for time period T, if it will produce a heat H, to the same conductor for the same time, same resistance, instead of AC, if you pass a DC current, and if it will result also the same amount of heat is produced, then this DC current pass is said to be root mean square value of current. So that is nothing but a general definition. I tried to explain you by using this diagram. Now we are going to find out its average value, sorry, root mean square value. So to find out root mean square value, just we have to solve the mathematical part that just we have drawn for initial part also. Average value we have done, same thing we have to do here. So IRMS square, IRMS is nothing but what? Root mean square value of current is equal to the integration varies from 0 to 2 pi. Integration varies from 0 to 2 pi I square d theta divided by 0 to 2 pi d theta. Same way just we have done initially also. I square 0 to 2 pi d theta, and this value come to be d theta means theta, upper limit 2 pi minus 0 means it comes to be 2 pi. Directly in your book they have written 2 pi, so we'll write 2 pi. Its value is coming to be 2 pi again. So just we go according to book, so it is 2 pi. So just take 1 divided by 2 pi common and just I put the value of I here. Just we can write this as equal to 1 divided by 2 pi integration of 0 to 2 pi. Now we know what is the value of I square is here, but I is equal to what? I0 sine omega t, as I equal to I0 sine of omega t. Just take it square. Just take it square and put it here. What we get? I0 square sine square omega t. I0 square sine square omega t, or just instead of omega t they have put theta, so we make it theta here. So I square sine square theta into this d theta as it is, into that d theta as it is, we get this equation. Now here those who have mathematics or those who don't have mathematics up to 10 standard, might be all of you are learn sine square theta can be written as 1 minus cos 2 theta. Trigonometric formula, sine square theta is 1 minus cos 2 theta. So just I0 square taken common, so we can write this equal to I0 square divided by 2 pi as it is. I0 square taken common. Sine square theta is what? 1 minus cos 2 theta divided by 2. 1 minus cos 2 theta divided by 2. This is in the bracket, this is theta, this is integration 0 to 2 pi. So what we have done, sine square theta is 1 minus cos 2 theta divided by 2. Now take this 2 outside. So what we get? I0 square divided by 2 pi earlier into 2. This 2 also we have taken outside. Okay, so that become like this. Now here, if this 2 is taken, what is the integration of d theta into 1? D theta, it is theta. What is the value of theta? Just we will find out later. So it becomes what? Theta. This comes to be theta minus cos 2 theta. What is the integration of cos 2 theta? Cos theta is converted into sin theta. So cos 2 theta can be written as sin 2 theta divided by, it is 2 theta divided by 2. So it is sin 2 theta divided by 2. This cos 2 theta integration we have find out by this formula. It comes to be sin 2 theta divided by 2, and where this whole thing has a same limit 0 to 2 pi. Put instead of theta 2 pi, upper limit minus lower limit as 0. Solve it further. What we get? I0 square divided by 2 pi into 2. Okay. Theta, instead of theta put 2 pi first here. 2 pi minus 0, it is 2 pi. 2 pi minus 0, it is 2 pi. So we can write here inside the bracket, it is 2 pi. We have find out the upper limit minus lower limit. Minus sin 2 theta divided by 2. Just sin 2 theta. Put theta equal to 2 pi. 2 into 2, 4 pi. Sin of 4 pi is what? 0. So it comes to be 0. Sin up to 4 pi is 0. So it comes to be 0. So this 2 pi cancel with this 2 pi. What we get? I0 square by 2. That is IRMS square. IRMS square is I0 by 2. I0 square by 2. We have find out this value. Okay, now further this I0 square by 2, we are interested to find IRMS. So just I will write it here. So what we can write, IRMS, take its square root, IRMS equal to I0 by 2, it is root 2, because this 2, I0 by root 2. 1 by root 2, 1 by root 2 is what? It is 0.707. So 1 by root 2 is 0.707. So we can write this equal to 0.707 into I0, that is IRMS. So you should remember this and this equation. This will give the value of RMS current. Similarly, you can write the ERMS equal to E0 by root 2 equal to 0.707 E0. So this is the formula for RMS current and RMS EMF that we have derived up till now. I hope all of you got what is the formula we have done, how to see the RMS value of current and RMS value of voltage or EMF that we have derived. Apart from this, just if you remember, when we start the RMS value, we have seen the amount of heat produced while passing a AC current and DC current. If the heat produced is same, then that DC current pass is said to be IRMS. Same thing, just they have below that they have done the same thing. They try to find out the heat produced, amount of heat produced, H equal to, the time varies from 0 to 2 pi by omega. As we know, T equal to 2 pi by omega, where T is a time period. So that 2 pi by omega, I square T RT. I square is a function of time into R is a resistance and time is a dt. I square R dt. Within time dt, current of I passing through the resistance of conductor is R, then the heat produces I square R into dt. Now in this case, we have to solve this. Just suppose I have taken this R outside, we can write this as a R, okay, integration 0 to 2 pi by omega. Now I want to make this T as a omega T. So multiply and divide by omega. So I have divided by omega here. Inside, what is that? I square omega T into d omega T. I square omega T into d omega T. Now in this case, again, just if you want to solve it, again we can take R by omega as it is, R by omega as it is, and if you find the integration of I square omega T, I square omega T by putting the value of I equal to I0 sine of omega T. Sine square omega T, between this 0 to 2 pi by omega is 1, sine square omega T is 1. What is remaining? I0 square and divide by 2, that part is remaining. I0 square by 2, that part is remaining. So I have written it as a I0 square, because if we take this integration of sine square omega T, it comes to be 1 by 2. That's why I0 1 by 2 it comes. So sine omega T in sine square omega T is 1 by 2. So the 2 is remaining. So I0 square by 2 is the remaining term here. Now here, what is the remaining term? Integration 0 to 2 pi by omega d omega T. So d omega T means what is integration? If you find out, it's come to be omega T. Put the value here. So we can write R by omega I0 square by 2 in the bracket. What we get here? Omega T. Limit varies from 2 pi by omega to 0. Put upper limit minus lower limit. R by omega I0 square by 2 as it is. Upper limit is what? Instead of T we have to put this, so inside the bracket omega as it is, T means 2 pi by omega minus omega into 0. This term will be 0. This omega cancelled out. What we get? 2 pi r I0 square divided by 2 omega. 2 pi r I0 square divided by omega that we get here. So that is nothing but what? If we solve it here, 2 pi by omega, we get r into I0 square by 2. So omega I0 square by 2. So that will come like this. And if this is nothing but amount of heat produced during this I0 square by 2, this term I0 square by 2, that is nothing but what? Just if you remember that I0 square by 2 I have written here. As we know, IRMS, I will write here, equal to I0 divided by root 2. So IRMS square equal to what? I0 square by 2. So put here. So what we get? Amount of heat produced is what? 2 pi by omega into R into IRMS square. So this heat is produced during passing a AC current as well as passing a DC current, that is nothing but RMS value. This much amount of heat is produced in this, and that they have told here. So that I have just drawn this value as according to the book. We have just derived this derivation. Now let's go further for next part of this. What they have done, they have just solved the different parameters. Before solving the different parameters, just we have to see the phasors. What is meant by phasors? Phasors are nothing but what? The EMF and voltage. EMF means voltage. EMF and current are represented in terms of rotating vector, and that rotating vectors are said to be phasor, and the diagram which will give the rotating vectors are said to be phasor diagram. For example, when we represent current by the equation I equal to I0 sine of omega t and EMF E equal to E0 sine of omega t. If current is represented by this, EMF is represented by this, then you can draw the phasor diagram for this. That is nothing but like this y-axis and x-axis we should take, and here we have to take a current. We have to take a current peak value, that is nothing but I0. We have to take current peak value I0, and this will be give the sine term along y-axis, sine of omega t, sine of omega t, and here it is I0. It is I0 sine of omega t is nothing but the value taken along y-axis, and this angle with the x-axis for this term. Similarly, instead of sine, if you take I equal to I0 cos of omega t and E equal to E0 cos of omega t, then the same diagram can be written like this. Again here it is I0, and instead of taking along y-axis, as it is term of cos, we should take it along a I0 cos omega t along x-axis. So this diagram which will give the relation, here, again this angle between this, which will give the relation between these vectors that we had drawn, that is nothing but EMF vector. This EMF or current was represented like this, then that diagrams are said to be phasor diagrams. Okay, so that might be you are not getting that much in this. Don't worry if you don't get phasor diagram now. In the next topic we are going to learn particular topic. In that topic definitely you understand what are the phasor diagrams. Okay, so first of part we have to start this part. Up till now we have said this is the basic part of the chapter. Actual chapter starts now. Now here different type of AC circuit we have to learn under this, as the chapter name is AC circuit. Different type of AC circuits we have to learn. The first part they have taken as AC applied to resistor. AC applied to resistor. If we have taken a resistance and to that resistance we have applied the AC, what are the outcome that we have to learn? So we might be all of you learn about this. This is symbol for resistance, and to this resistance we have applied the AC EMF E equal to E0 sine of omega t. This R is a resistance. R is a resistance, and across this resistance R we have applied the AC E equal to E0 sine omega t. Now according to Ohm's law, if you remember, V equal to I into R. This is said to be Ohm's law. In our case, what is V? V means EMF E, and suppose the current passing due to this EMF is small I, and R is nothing but a resistance. So this is Ohm's law. We have written Ohm's law. and that Ohm's law is applied to our circuit. E is EMF and suppose this I is a current produced. So E equal to I into R, that we have represented here. Now here, as we know, E equal to IR, but here E equal to E0 sine omega t. So we can write equal to E0 sine of omega t. Just we have written the same thing, E0 sine of omega t. From this, find the value of I to this side, this 2 part. I equal to E0 divided by R into sine of omega t. Now this term is nothing but a peak value of current that was represented by I0. We can write I0 sine of omega t. I equal to I0 sine of omega t. So we started from the EMF. We have the EMF equation. We have derived the current equation like this. If we see E equal to E0 sine omega t, I equal to I0 sine omega t. Both the EMF and currents are seen to be same, and from this equation just point to be remember E0 by R is I0, peak value of current. E0 by R is I0, peak value of current. Point to be remember is what? In both the equation, as both are the sine terms are there, so both the equation says that the whatever be the change in EMF, same change occurred in a current. Whatever be the change in EMF, same current occurred in a current. Now that was represented by the diagram. That diagram was given in your book. I will try to draw that diagram. Suppose EMF is taken. Suppose we have drawn such type of things. Such type of things we have drawn according to the book. And if we draw the dark line like this, goes up, comes down, and like this. Okay. This is the first part I have drawn, and it goes up further. Okay. So the black color lines I have drawn first. Then we are going to draw the another color, that is nothing but what? Blue color graph. So this is dark color we have drawn. Now blue color graph we are going to draw. So suppose it goes up, again comes 0, again goes up like this. The same point they are must go. So it is going from the same point. Whatever be the change in current, the same change would be there in voltage. If we see these things we have done. Now if we represent this blue color as it is represented current. Current means I. This black line, if that black line represented EMF, EMF by E. The two curves we have drawn here, if we see, they will start at 0 at a time. They becomes maximum at a time. So at this point they are both maximum. They become 0 at the same time. Again maximum in negative direction at the same time. Again 0 at the same time. Means what? Their starting point is same. Their intersection is at the same point. They are intersecting equally, means what? The EMF and current are exactly in phase. How they are in phase? We have represented E equal to E0 sine omega t, I equal to I0 sine omega t. So these are the two curves we have drawn, and from this they are changing similarly, and that's why here this is current. So this value stands for I0, peak value of current. This stands for E0, peak value of EMF. From this diagram it is seen that EMF and currents are in same phase. Equally they are changing. They will start at the same point at the same time. They become maximum at the same time, and so on. Equally they are starting. So we can say when AC is applied to resistor, it is seen that current and EMF changes equally. They are always in phase. They are moving always in phase. That topic we learn from this, the first point, when we apply AC to resistor. Apart from this, phasor diagram of the same we have to draw. So just in your book, figure 13.5 is there. That will give the phasor diagram. I will draw it here. So phasor diagram for this AC applied to resistor is nothing but they have drawn like this. Then they have taken this as a middle line, and this is nothing but omega t. That is nothing but omega t angle. And here they have taken, suppose E0. E0 is moving here, and this value becomes E equal to E0 sine of omega t by default then. And as I0 also move in the same direction, so we will take I0 somewhere here. It is moving in same direction. So this parameter is I equal to I0 sine of omega t. Both of them are moving in the same direction, and here this part is nothing but a current I, and this part is nothing but a EMF E. Now this diagram is said to be phasor diagram for current and EMF. It is x-axis, it is a y-axis by default, we know that. So this is a phasor diagram for this. The next one, AC applied to inductor. If we apply the AC voltage to the inductor, what will occur, that we have to learn in that topic. Now I think it's 25 minutes, 35 minutes are over. The lecture becomes very big. That's why we stop here. In next period we will see when the AC applied to inductor, what will occur. So what all of you have to do today, you just watch this video first. After watching, try to understand, and once you have watched the video, then read the same topic from your book. It will increase your understanding, and again then see the same video again. So this will confirm your all the concepts get clear. Still, if you have any problem, you can contact. So let's see you in the next period with the AC voltage applied to inductor. Thank you.